How to create a video chat app in Unity. All apps become more fun when users have the ability to see and interact with each other. Games have been including voice chat services for years, but when it comes to video, there are limited options, especially when using Unity. The best option I found is the Agora.io Video SDK for Unity, available through the Unity Asset Store. In this guide, we'll walk through all the steps you need to build a cross-platform video chat mobile app using Unity. Some prerequisites you will need is Unity Editor, an understanding of the Unity Editor, game objects, Unity scripting, and publishing Unity apps to mobile devices, a basic understanding of C#, and an Agora.io developer account. Please note, while no Unity knowledge is needed to follow along, certain basic concepts won't be explained along the way. Before we dive in, let's take a moment to review all the steps that we will go through. 1. Set up new project and import Agora.io Video SDK for Unity. 2. Create welcome and chat scenes. 3. Create a script to handle button taps. 4. Create a script implementing the Agora SDK. And 5. Build and test on iOS and Android devices. To start, let's open Unity and create a blank new project and name it Agora Video Demo. Once Unity finishes setting up the project, we'll navigate to the Unity Asset Store and search for Agora Video SDK. Next, we'll import Agora.io Video SDK for Unity into our project. When the prompt appears, make sure all the assets in the list are selected. Now let's create a new scene, name it Welcome Scene, and double-click the scene to open it in the editor view. The welcome scene will be the first screen the user sees once the app loads. To start, we're going to remove the existing camera and lights from the scene. First, we will add a canvas game object. Next, let's add a camera as a child of the canvas. Since the screen is meant to be displayed in 2D, let's switch our editor to 2D mode. We are going to need a button that will trigger the app to join the chat. So we'll add a button and name it Join Channel and give it a label. Let's also switch our editor view into game mode so we can visualize placement relative to the camera view. Let's adjust the scale and position of the button. We also need a way for the user to input their channel name, so let's create a text input and name it channel name. And give it a meaningful placeholder text. We should add a text box to explain a little bit about our app. Create a text game object as a child of the canvas. You can find my example below in the description. Let's take a moment to adjust the positions of each so we have ample space between game objects. Next, we are going to create a new scene and name it Chat Scene. This will be the screen with the local and remote streams playing. To test out some of the capabilities of Agora I/O Video SDK, let's add a few shapes to our scene. Let's start by adding a cube to our scene. Since our scene contains 3D, let's exit 2D mode in our editor. Now we have a better view of our cube and it's looking a bit small, so let's change its scale to 2 on all axes. We want our cube to render the local camera stream as a texture. We need to add videosurface.cs as a component of our cube. Let's add a cylinder game object. First, we need to move it up so it's not hidden by the cube. Next, we'll give the cylinder a unique scale and making sure to add the videosurface.cs as a component. Lastly, we are going to add a canvas to the scene. This will allow us to also add in our 2D button to leave the chat. We'll call it Leave Button. And give it a proper label. While we're at it, let's add a text box, name it version text. We can use it later to give us a visual confirmation things are working. Let's place the version text in the upper right hand corner to keep it out of the way and set the color to white to make it easier to see. During the process of setting up our scenes, we created 2 buttons, Join button and Leave button. So now we need to create a script that will connect some actions to those buttons. Start by creating a new C# script in our assets. Name it buttonhandler.cs. And double click it to open the file in Visual Studio. Let's add a single function, onButtonClick, and to keep things simple, let's add a debug log to the body of our function. Let's go back to our welcome scene within Unity and connect our script and function to our button. First, select the Join button and add the button handler script as a component. Next, add an event and map the button click to an on button click. We'll repeat this process for the leave button within the chat scene. Now that we have 2 buttons invoking the same function, let's add some logic to differentiate between the two. To prepare for our Agora implementation, let's add a couple lines to get the user input from the channel name field. We can get the input field component from the channel name game object. We'll need to include the UI library Create a script implementing the Agora SDK. To start, we'll create a new C# script in our assets, name it agorainterface.cs, and open the file in Visual Studio. The first variable we'll create is app ID, and this will hold our Agora app ID. Take a moment to log into your Agora developer account and get your app ID and paste it into the value of app ID. We also need to create a variable to hold a reference to the Agora RTC engine and a placeholder variable for the ID of the remote stream. Let's create a function to initialize the Agora RTC engine. We'll call it loadEngine. We need to make sure the engine is only initialized once, if the engine doesn't already exist. If true, we'll use the irtcengine.getEngine, passing in our Agora app ID to initialize the engine. Here we can also set the log level to debug, so we can see our debug logs and that everything is working as expected. As you can tell by now, I like to add lots of debug logs to give us a clear understanding of what's going on during execution. Next, we'll declare the join channel function. we'll use an if statement to check if mRTC engine reference is null. First checking that the RTC engine exists, then we'll enable video and enable the video observer. Finally, using the channel name, we'll call join channel. So far, we've initialized the Agora RTC engine and used it to join a channel. But now we need to add a way for users to leave the channel and unload the engine. We'll start with leave channel. Again, we check that the engine exists, and then using the engine, call leave channel and disable video observer. Lastly, we'll unload the engine by calling irtcengine.destroy and setting the local reference to null. The engine's basic lifecycle events are accounted for, so we are ready to add some callback functions that the engine can call based on various predefined events. The callbacks we're going to focus on are on-channel join success, on-user joined, and on-user offline. On join channel success will get called whenever the local device successfully joins the channel. For now, let's leave the onJoin channel success function with just a log. We'll revisit this later. OnUserJoined will get called whenever a remote stream joins the channel. OnUserOffline will get called whenever a remote stream leaves the channel. After we define each function, we'll notice the editor has stopped complaining about the errors on lines 35 to 45. Within the onUserJoin function, we'll add some logic to create an empty game object and initialize it as a plane. Let's set the name of the game object to the remote stream UID so we can easily reference it later. Since we want to use this plane to render the remote stream, we need to add a video surface component to the game object. And we'll set the video surface to use the remote stream's UID. And use setEnableTrue to enable rendering on the plane. Let's set the scale and randomly position the plane somewhere on the y-axis. As an example that the video plane does not need to remain stationary, we'll add a transform delegate to the video surface on update so we can see the plane rotation around the x-axis. To finish up the callbacks within the onUserOffline, Let's add some logic to destroy the game object created within the onUser joined. Let's add the transform delegate function to skew the shape of and rotate any game object that calls this function. You may have noticed that within the transform delegate, we added some logic for when user ID equals 0, which is only true if we call the transform delegate on a video surface with a local stream. Let's jump back to our buttonhandler.cs script and add the logic to connect to the channel and leave the channel. We will start with the onJoin button clicked function. We need to first check the engine exists before trying to connect to the channel. Then we will call join channel, passing in the text input as the channel name. Upon joining the channel, we'll call the chat scene, so we need to include the scene management library. After we tell the engine to join channel, we need to add a call to the scene manager to load the chat scene in single scene mode. Next, let's move down to the onLeave button clicked. Again, starting with a check that the engine exists. If the engine is not null, then we can call leave channel, unload engine, and reset the reference to null. After the user has disconnected from the channel, we need to return them to the welcome scene. So we use the scene manager to load the welcome scene in single scene mode. To show how Agora's engine can be called across scenes, let's add in a function to Agora interface.cs called onChatLoaded. Later it will be set as a callback whenever the chat scene has completed loading. We start by getting a reference to the cylinder in the chat scene, and adding in a debug log in case there's an error. Next, we will use the game object to get a reference to the video surface component and attach the onTransform delegate. The last step is to go back to buttonhandler.cs and add logic to call onChatLoaded. Within the onJoin button click, just after we call join channel, we'll add a callback to the scene manager's scene loaded listener and call it onScene finished loading. Since the callback will get called every time, we need to have an intermediary function. Within onScene finished loading, we'll check the scene name to make sure it's the chat scene. Here, we'll double check that the engine exists and then call the onChat scene loaded function. Lastly, we'll remove the listener so the action doesn't compound every time we join the channel. One thing we need to do before we can test our work on device is to add some permissions requests for Android. Starting in Unity 2018, the permissions are no longer added automatically. So we need to add a few if-else statements to check and request permission for microphone and camera. Lastly, let's add some logic to fill in the version text whenever we successfully join the channel. To do this, let's go back to the Agora interface.cs script and declare the function getSDKVersion that returns the SDK version from the Agora RTC engine. Now it's time to connect this function with the on-channel join success that we created earlier. We'll find the version text game object and set the text equal to version plus get SDK version. It's finally time to test out our app. Let's go back into Unity and open the build settings. First, we'll drag the welcome scene and chat scene into the scene list within the build settings dialog box. Before we can build and deploy our app, we need to take some adjustments to the player settings for each platform. Select iOS from the platform list and open the player settings. First, we need to deselect the Auto Graphics API option. Make sure only OpenGL S2 is on the list. We also have to deselect the multi-threaded rendering option. Let's update the bundle ID and provide some text for the camera and microphone usage descriptions, which enables the permission prompts. Let's select Android from the platform list and follow the same steps as iOS. Open the player settings, make sure we are using OpenGL S2. Have disabled multi-threaded rendering option and provided a package ID. We are now ready to build our app. Within the Build Settings dialog, select iOS and click Switch Platform. Once Unity has finished loading its scripts and platforms, click the Build button and Unity will prompt you for a location to save the build. I like to create a build folder to keep things organized. Save your build within the newly create build folder and save our build as iOS. After Unity finishes building the iOS app, the Finder window will appear containing the Unity-iPhone.xcode project. Double-click the file to open Xcode. Once Xcode is open, select the project from the File Navigator on the left and enable automatic signing and select your team profile. Lastly, make sure your test device is plugged in and click the Play button. You can see the welcome scene loads first. Then when we join the channel, we are taken to the chat scene. Back to the welcome scene when we click the leave button. The only thing missing is the remote stream, but for that we need a second device. At this point, we could plug in another iOS device and run the demo app again, but that's not fun. So let's go back into Unity and build the project for Android. Let's select Android from the platform list and follow the same steps as iOS. Make sure your Android device is plugged in and click build, and run. Unity will prompt you to save your project. I name my build Android. Pat yourself on the back because that was a big one. Well done. Thanks for following along. Feel free to leave a comment below.